So on the first one, having this fraction bar across here means you have to do everything on top first. So I'm going to start out by doing the multiplication. 3/4 times 8/9. Cross cancel the 3 and the 9 to give me 1 and 3 because they both divide by 3. 4 and 8 can both be divided by 4 to give me 1 and 2. So that is 2/3 squared. How do we square a fraction? Yes, 2 squared, which is 4. 3 squared, which is 9. On bottom, 2/3 plus 5/6. We need a common denominator. It is going to be 6. So the 5/6 stays the same. 2/3 becomes how many 6? 4. Very good. 3 times 2 is 6, so 2 times 2 is 4. So now we're going to add 9. 4 plus 5 is 9. 6. Both 9 and 6 can be divided by 3 to give me 3/2. Now I could reduce that to 1.5, but I don't want to at this point. The reason being is I know that my next step is going to be to divide, and when I divide, I need it as an improper fraction anyway. 4/9 over 3/2 is 4/9 divided by 3/2. So that's going to be 4/9 times 2/3. So 4 times 2 is 8. 9 times 3 is 27. So that becomes 8/27. How many people had 8/27? Show of hands. Okay. Any questions? Any spots in there where I lost you and you want me to go back and go through it again? Okay, do you guys need a couple minutes to do the second one? Yes? Okay, I'll give you another minute or two for that one. Okay, so what do we have to do first? The parentheses. 7/8 minus 1/4, of course, subtracting, we have to have the same name. So that name is going to be, common denominator is going to be 8. So this will stay 7/8. This is going to become 2/8. 7 minus 2 is 5/8. Now, of course, the 1/2 in front there is multiplied. Now what? We'll do 1/2 times 5/8. Nothing to cross cancel, so 1 times 5 is 5. 2 times 8 is 16. And now, subtract. 3/5 minus 5/16. I'm going to write it over here because this one's going to take a little effort. So subtraction. Common denominator is going to be 80. So 5 times 16 to make 80. 3 times 16 is 48. 16 times 5 to make 80. 5 times 5 is 25. So now I subtract. 48 minus 25 is 23/80. So this here is replaced with 23/80 plus, that is 3/2. Oh, I didn't. It's still 3/10. So it's plus 3/10. Thank you. That's just my mind playing tricks on me in the evenings. So we have 23/80 plus 3/10. Common denominator is going to be 80. So the 23/80 will stay. This is going to become 10 times 8. So 3 times 8 is 24/80. And we add 23 plus 24. 47/80. Questions? Okay. Yeah. Well, remember, you do have the fraction function on your calculator, too, that you
I
can
know,
use.
but I used it on the first one and it came up with 1.5. That's what my calculator showed.
1.5 on the first one.
Yeah, not the 8 and 27.
Huh. Now, when you do that, make sure you do, something like this. I would do the top all at once, then I'd do the bottom, and then I'd divide the two answers. Usually it's easier to do that. Because a lot of times entering a complex fraction like that, you got to have parentheses in the right places, and the calculator messes it up. If you're having problems with the calculators at the end of class, I'll take some time and go through them with you again if we need to. Some other things that I want to make sure we review, just to make sure you remember how to do them. Try that one in your notes, just to make sure you've got her down.
Is that 1.9 or 19?
That's 19. There. That was just my cursor was looking. Sorry. So to solve something like this, what's our first step going to be? Add 5. To get rid of the -5, so we have to add 5 to the other side as well. So on the left side, all we have is the 3x anymore. The -5 is gone. Over here, 19 plus 5 is 24. And then divide by 3. X equals 24 divided by 3 is 8. Look familiar? A little bit? Okay. So, we've been working with fractions. So it's time to bring fractions into some of the other things we've been doing. We did word problems. I could do a word problem like this, that we have an 18-foot by 26-foot pool. We plan. What's that?
51 by 32.
51 by 32 foot pool? That's huge.
And then you've got a 2.5 foot perimeter around the outside.
You plan to put 2.5.
All more questions.
I was kind of sensing that. You plan to put a 6-foot deck around the whole pool. What are the final dimensions? Well, I like to sketch out pictures for things like this because pictures fit pretty well. The pool is 18 feet by 26 feet. Now the deck, we're going to assume it's out of wood, so I'm going to make it brown, is 6 feet wide. So all the way around the pool, we're going to put this 6-foot wide deck. And we want to know the final dimensions, the overall dimensions. Well, that would be from here to here, which is going to be how long? Well, 26 plus 6 plus another 6, right? It's going to be 38 feet. How about this dimension? Well, it would be 18 plus 6 plus another 6. Or 30 feet. So the overall dimensions are going to be 38 by 30. let's say that Pat has a pool that is 16 1/4 feet by 24 3/4 feet, and plans to build a 6 1/2 foot deck around it. Once again, find the overall dimensions. Well, after seeing the last problem, the process should be relatively clear. We have the pool, which is 16 1/4 by 24 3/4. We're putting up a deck around it like that, and that deck is 6 1/2 feet. In each direction. I'm not going to label all of them. So to find this dimension here now, it's going to be 24 3/4 plus what? 6 1/2 and another 6 1/2, which comes out to be 37 3/4 feet. Going the other way, this is going to be the 16 1/4 plus 6 1/2 plus another 6 1/2, or 29 1/4 feet. Not so terrible. Drawing the pictures helps out a lot. In fact, the next example I'm going to do, a picture is almost vital. There's really be tough not to do it without a picture. So in this next one, a bookshelf is 40 3/4 inches tall. The bottom shelf is 3 7/8 inches off the floor. The top is 1 1/8 inches thick. And each of 3 interior shelves is 5/8 of an inch thick. Find the space, assuming they're all spaced equally, between each shelf. Like I said, almost impossible to do this one without a picture. So let's draw a picture of it. Here's our bookshelf. We are told it was 40 3/4 inches tall. Also told that the bottom shelf is how far off the ground? 3 7/8 inches. That's the top of the bottom shelf. So whatever thickness that shelf is below that. The top of the shelf itself is 1 1/8 inches. And then there's 3 interior shelves. That are supposed to be equally spaced, so pretend those are equally spaced. that are each 5/8 of an inch thick. So what we have here is we have the empty space that is divided into 4 equal spaces. We need to figure out how big each of those spaces is. So what I would do is I would add up the total room taken up by the shelf thicknesses in the top and the bottom. So I'm going to add up 1 1/8 plus 5/8 plus 5/8 plus 5/8 plus 3 7/8, which is what? 6 7/8, isn't it? Is that what you guys get? 1 1/8, 5/8, 5/8, 5/8, and 3 7/8. They're already all in eighths. So we've got 1 5 is 6, plus 5 is 11, plus 5 is 16, plus 7 is 23/8, which is 2 7/8. Keep the 7/8, carry the 2. 1 and 2 is 3, plus 3 is 6. So it is 6 7/8 inches. That's the space taken up by the shelves. What are we going to do with that 6 7/8? We'll take it away from the overall height. 40 3/4 minus 6 7/8. So we need a common denominator, which is going to be what? 8. So the 6 7/8 doesn't change. 40 3/4 will become 40 and how many eighths? 6. 4 times 2 makes 8, so 3 times 2 makes 6/8. We go to subtract. 6/8 minus 7/8. Can't do it. So we got to borrow. This is 39. What's this become? Remember, when we borrow, it's the denominator that tells us how much we borrowed. One full object is 8 pieces, so 6 plus 8 is now 14/8. 14 minus 7 is 7/8. 39 minus 6 is 33. So there's 33 7/8 inches of empty space left over. So that's the empty spaces after we take out the thickness of the shelves. So what are we going to do with that number to get how big each space is? How many spaces are there? There's 4 spaces. 3 shelves cut it into 4 equal spaces. That's where the picture becomes vital, because having the 3 shelves you can see from the picture, it has to be 4 equal spaces. So we're going to divide by 4. So we got to change this into an improper fraction. 33 times 8 is 264. Plus 7 is 271 over 8. Divided by 4, we'll make that a 4 over 1, means times 1 over 4. So that's 271 over 32. So 32 goes into 271 8 times, which is 256. So there's going to be 15 left over. So it is 8 and 15 32nds of an inch is what each space is. See how simple that is? I probably wouldn't do that to you on a test, just so you know. Probably. Well, you guys could really do something to upset me between now and Thursday, you know. Don't worry, I sent out the test this afternoon, so the test is already in your Richmond, so I really can't change it. Okay, so some other applications where our fractions are going to come into play. Something like this. Now you look at this and you tend to lock up because there's fractions in it. When we're solving equations with fractions, if you haven't done that before, you get nervous. But one of the simplest equations there is to solve is one that looks like this. And what did we do to solve that equation? We divided by 3. X equals 5. We divided by 3 because the variable x had been multiplied by 3. Over here, the variable x has been multiplied by 5, 6. So to solve it, we're going to divide by 5, 6. So that's going to cancel out, leaving us with x. But over here, of course, it's a little more work, because we got to do 3/4 divided by 5, 6. Can I cross cancel the 3 and the 6? No. Why not? Because right now it's still division. The 3/4 is going to stay, but we're going to change it into multiplication by multiplying by 6/5. Now we can cross cancel. 4 and 6 can both be divided by 2 to give me 2 and 3. So now we multiply 3 times 3 is 9, 2 times 5 is 10. So x is 9/10. Questions? Oh, yeah. So 5/8 x equals 2 and 1/2. So again, x has been multiplied by 5/8. So we're going to take this equation apart by dividing by 5/8. Very good. So that's gone. We get x equals. So here we have 2.5 divided by 5/8. So I'm going to change this 2.5 to 2 times 2 is 4 plus 1 is 5/2, and then times 8/5. 5 and 5 can cross cancel, both divided by 5 to give me 1 and 1. 2 and 8 can both be divided by 2 to give me 1 and 4. 1 times 4 is 4. 1 times 1 is 1. 4 over 1, or just 4. X is 4. We could have x plus 2/3 equals 5, 6. Again, the fractions make us lock up, but this is exactly the same as if I had x plus 7 equals 13. How did I solve this equation? I subtract 7 from both sides. So that's gone, leaving with x equals 13 minus 7 is 6. Over here, what am I going to have to do? Subtract 2/3. So the 2/3 is gone, leaving with just x. Over here, I need a common denominator, which is going to be 6. That stays 5, 6. This is going to become, 3 times 2 makes 6. 2 times 2 is 4. So 4, 6, and it is still minus. 5, 6 minus 4, 6 is 1/6. How are we doing so far? No? Okay. So we might have x plus 2 3/8 equals 5 1/4. What are we going to do to solve this one? Subtract 2 3/8. So it's just gone here, leaving us with x. On the other side, we need a common denominator, which is going to be 8. So the 2 3/8 stays the same. 1/4 becomes 4 times, you got it, 4 times 2 makes 8, so 1 times 2 is 2, so it's 2/8. So we go to subtract 2/8 minus 3/8. We got a problem. So we're going to borrow from the 5. This is a 4. This is going to become plus 8. So 2 plus 8 is 10/8. So now 10 minus 3 is 7/8. 4 minus 2 is 2. X is 2 7/8. So, in your notes, solve that one. So what do we have to do? X has been multiplied by 2 3/5, so we're going to divide by 2 3/5. So 4 1/3 divided by 2 3/5. First step is to make them improper. 4 times 3 is 12, plus 1 is 13/3. 2 times 5 is 10, plus 3 is 13/5. And then, so, perfect. We're dividing by 13/5. We're going to change it to times 5/13. And of course, the 13ths will cross cancel, leaving us with 5/3, or 1 2/3. How many of you had 1 2/3 for that? Okay. Anybody lost as to how we got 1 2/3? Right. It's just a matter of doing the operations with the fractions. So it's a little bit longer, same process, just longer calculations. Yeah, you bet. Actually, let me do this. Let's try that one. So here, the variable's been multiplied by 1 1/8. And then 2/3 has been subtracted from it. So to reverse that, we're going to first add 2/3. So that'll be gone. Leave us with 1 1/8 x. Over here, we're going to add 2/3. So we have to find common denominator, which is going to be the 6. So it's still 1/6. This is going to be 4/6. 3 times 2 makes 6. 4 times 2 makes 4. So then 1 plus 4 is 5/6, and then the 4. This is 4 5/6. So now it's 1 1/8 x equals 4 5/6. We're going to divide by 1 1/8. So x equals 4 5/6 divided by 1 1/8. 4 times 6 is 24, plus 5 is 29/6. Divided by 1 times 8 is 8, plus 1 is 9/8. Comes 29/6 times 8/9. We will cross cancel the 6 and 8, can both divide by 2 to give us 3 and 4. So 29 times 4 is 116. 3 times 9 is 27. 116 divided by 27, it goes in there 4 times, which is 108, with 8 left over. So x is 4 8/27. Anybody get that? A few? Ran out of time?
Mixed up my numbers again.
Okay. That's okay. I've been having one of those afternoons too where I've been switching numbers and trying to read the problem and I'm saying the answer rather than reading the problem. So don't feel bad. So a little notation that we really haven't seen yet, at least not much. There's two different ways we can interpret this. X over 7 equals 5. I can interpret that as x divided by 7 equals 5. And if I look at it that way, I can solve it by simply doing what? Yeah, if x has been divided by 7, we're going to solve it by multiplying by 7. It's gone, so we got x equals 5 times 7 is 35. Now, as always, we can substitute back in. If x is 35, does 35 divided by 7 equal 5? Well, it sure does. The other way we could interpret that is instead of x is divided by 7, we can interpret it as 1/7 times x, or 1/7 x. Now, we're going to solve this, since x is multiplied by 1/7, we're going to solve it by dividing by 1/7. Well, when we divide by 1/7, what we end up doing, of course, is multiplying by 7 over 1, which is 35. So we get the same answer either way. The reason I show you this here, though, that interpreting instead of x divided by 7, interpreting it as 1/7 x, is because we can run into problems like this. If I look at that, I can't just multiply by 5 and make anything happen. X has been divided by 5. This one's been divided by 5, but this one's been divided by 7. So to work with that, one of the interpretations is I can read it as 1/5 x plus 1/7 x equals 24. Now you might be looking at that and say, how does that make it any simpler? Well, it really does, because now it's the same as having like 2x plus 6x equals 32. What would I do with something like this? Yeah, I'd combine 2x and 6x makes 8x. Now 8x equals 32. Well, the same over here. I'm going to combine 1/5 x and 1/7 x. So I have to add 1/5 plus 1/7. Common denominator is, of course, going to be 35. This is 7/35 and 5/35, so it gives me 12/35. So this becomes 12/35 x. I just added 1/5 x and 1/7 x.
24 equals 24.
What's that?
It equals 24 by 27.
24, thank you. See, I told you, my brain's shot for the day too. Yeah, thank you. That would have made the next step really interesting. Now that it's 12/35 x equals 24, I'm going to divide by 12/35. (24) divided by 12/35 is 70. Okay, I'll show you how. 24 divided by... I looked around the room and I saw those looks like, huh? Where'd that come from? So, 24 divided by 12/35 is 24 over 1 divided by 12/35. That's going to become 24 over 1 times 35 over 12. 24 and 12 can both be divided by 12, which will give me 1 and 2. So now 2 times 35 is 70. 1 times 1 is 1. So 70. You bet. Try that one in your notes quick. I'll give you a couple minutes. Okay, so we're going to change the x over 8 to 1/8 x and the x over 3 to 1/3 x. So we're going to combine the 1/8 x and the 1/3 x. So we have to add 1/8 and 1/3. We need a common denominator, which is going to be 24. This is going to be 3 24ths plus 8 24ths makes 11 24ths. Perfect. So now we have 11 24ths x equals 33. And we're going to divide by 11 24ths. So x equals 33 divided by 11 24ths is 72. How many of you got 72? Good deal. It is a great time to take our break. So let's go do that. We'll start our lecture. It's about 4:21 now. We'll start lecture at 4:31.